How's everyone doing? Last stretch, right? Is anyone actually going to go to the last session? I know I'm tired. I've been here for 5 days. Trevor and I have been here for the MVP summit. I was joking about putting on a 45-minute video, just when you guys watch it. So you guys are here for Solr, right?
Yes.
Containers? Okay. Alright. Okay, so containers. How many people know about containers? How many people know about Docker? How many people use Docker? Cool. Alright, so brand new. So it's gonna be interesting. Hope you guys are gonna get as excited as I am about this. I'm just stoked. First time I saw this, I saw Docker, I saw it in action, and especially when I tried it, just blew my mind. So the title was very long. Harness the power of containers, Solr, and Mongo. I changed a bunch of things, so it's just gonna be containers, it's gonna be Docker. We're gonna look how Docker applies to Sitecore, of course. So my name is Vasiliy, just Vasiliy, so don't worry about the last name. I'm a solutions architect at Ferndale. Sitecore MVP, technology enthusiast, passionate about innovation. Anything that has to do with innovation out there. I'm always trying to learn new things. Artificial intelligence, machine learning, Docker, things like that, just blow my mind. So I have a blog, CMS Best Practices. Twitter, I'm always on Twitter. Hit me up if you have any questions. Anytime, really, anytime. And then my LinkedIn. Like anyone who's go there. Does anyone use LinkedIn here? I came up to a bunch of you. I didn't bring my, well, I don't have business cards. It's like, I was hoping I would just, with a phone, I would just get people's information on LinkedIn. Who use LinkedIn? Seems like 3 out of 5 people said they don't really care. So anyways, so why are we here? So Docker, right? So we're here to solve problems, right? You're here because you're curious, you heard about it, you're wondering what it is. Actually, how many of you guys are developers? Cool. How many are in sysadmin work? Ops? No. Managers? Okay. Any other line of duty? Okay, cool. So just making sure how many people I got lost. So this is a combination of DevOps, so this really covers the whole spectrum, right? Developers, operations, management. We'll look at why. So we're here to solve problems. You're here to find out about containers. We're here about to find out what it is, how it can help you guys out, right? You're here about to get some knowledge, get something out of this, take home, try it out, test it out. So my goal is for you guys to understand what it is, how it works, why it's important, why it's so wildly successful. 18,000% growth in 1 year. Crazy. So ask me questions. I'm gonna go. Originally, that was meant to be an hour-and-a-half presentation. So I condensed it down to 45 minutes. I'm gonna try to fool Stephen Pope. I don't know if that's gonna work. So feel free to stop me anytime. Just raise a hand anytime. Don't worry about it. I'll stop and answer your questions. So don't wait till the end. Okay? You'll forget about it. So we'll look at how we do things today. We'll look at what containers are, how they apply to Sitecore world. Why do we care? Why is a Sitecore dev, as a Sitecore operations or a manager? Why do we care about that? We'll look at some demos, look at some cool stuff, and how can we use this information? We're gonna answer that question. So what's the problem? Why are we here? So what are the challenges right now? Right? What are the background on me, for me, why I'm so passionate about this, and why I'm so passionate about these problems and solving these problems. My background is was in sysops, system administration. So networking technology, computer administration, security. I was working in networking security for quite a while before I got into development. So this stuff is near and dear to my heart. So this is DevOps, right? Does everyone know what that means? And there's developers and ops, operations coming together. Developers in operations do development. So what are the problems? So Docker is really trying to solve a problem of shipping, right? So shipping software has been a nightmare for a long time, right? So, and since it was a nightmare, there are just a battery of issues with shipping software, with errors, with human error, with the process. We're trying to figure out all these hacks, and we're trying to figure out the scripts and what to do and how to just kind of hack our way through the development cycle, continuous integration. Well, Docker is here to solve these issues. So we have local environment setups. They're getting more and more complex. Look at Sitecore 8, right? Sitecore 7 introduced Solr, Mongo. Sitecore 8 is growing. Now we can split out the processing server, reporting server, delivery server, management server, collection server, plus any other custom data that you have. It's getting pretty complex. It's no longer just master web and core, right? So it's for analytics. Environment differences. How many times, developers, that's for you, how many times have you built something and then QA calls you up and says, wait a minute, that doesn't work? And what do? I wait. I wait for them to spend a little more time on it. Sometimes they reply, never mind, I fixed it. Never mind, I was just, and then you wait, but then there's another email, hey, it doesn't work. And then you reply, it works on my machine. You screwed up, so it's not me, works on mine, out of my hands. So then back and forth, right? So that's an issue. Manual setup is too complex, and we talked about that. So we're setting up Sitecore 8, just a battery of servers. We got to do a lot. It's no longer just a simple install, right? If you're installing it for a client, for instance, if you're installing it in production, it's no longer just install the server, hook it up, and do some tuning. There's a lot of work involved. Human error, of course, since it's a manual process, right? Human error, we're all humans. And I'm always fascinated by when people write software for like SpaceX or just hospitals. You can't make an error. And I know I make errors all the time, right? So there's human error. Scalability issues on-prem. As developers, we always spin things out locally. We have our development servers. But what if we need another one? What if we need to test something real quick on a clean machine? We can't do that, right? We have to spin out, well, we can go with a virtual machine, right? Then that takes time. But what if we're out of resources? I don't know about you guys, but my laptop is it's stretched on resources. I'm borrowing memory from Air. It's learned to do that. I have nothing left out of my laptop. I have probably about 15, 20 virtual machines, different virtual machines from Linux to Windows, just different environments. So there's no room for me. So if I try to get another machine from development, that's going to take a while, right? So and the bigger the company, the more cumbersome the process is, right? Scalability issues, inability to reproduce production environment. So let's say you've gone through QA, you got in production, boom, something blows up. An average time it takes to fix a production issue is 4.55 hours. The cost of fixing an issue in production, around $100,000, 110, I think, from the research. So there you go. But how does it break on production? But it works on local, but it works on QA. Everything tested out, breaks on production. Because differences in environments, right? For production, in there for a while, there's legacy code, legacy frameworks, legacy stuff that's not on your local RMK. Inability to easily sync up all Sitecore environments. So Sitecore, we promote content from offering to delivery, right? Once in a while, we need to sync that back. Once in a while, we need to bring that content back into QA, UAT, staging, and development, just to make sure we're still, the things we're building work well with the content in production. You can't easily do that. But what is there? Unless you're, especially if you're in a bigger company, right, corporation, you gotta get a hold of the DBA, And then you gotta jump through the hoops, you gotta jump through certain cycles and processes, and it's a nightmare, right? On your local, it's simple, copy the SQL file, right? And lack of QA and other types of reproducibility. So let's say QA found a bug, and they wrote the steps as they think what you should do, right? But then you go and do it, but it still works in your local. And then the whole cat and mouse game begins again, right? It works. No, you're wrong. No, this is what you do. Again, because our environments are different. So, this all stems from the problem of shipping software, right? So we're shipping software to QA, we're shipping software to different development machine, we're shipping software to production. And whenever there's a problem, I find in technology nowadays, whenever there is a new problem, it's often that we can find the answer in a different industry. We've already solved these problems. Probably 99.99% of the problems we've already solved. We just solved them in a different manner, in a different industry somehow. So thinking about deploying software and shipping helps realize that. We've been shipping stuff since day one, right? So what did that used to look like? So we've been shipping all sorts of things on ships and in all sorts of forms and variations, square, round, just bags of stuff, just all sorts. And we've been trying to, look at that, we've been trying to hack it, loading on the ships this whole time, right? Just like we're trying to hack the deployment process, the shipping process with software. So, how do we solve it there? Well, obviously know the story. It's in the name. Containers. How old do you think? How old do you guys think containers are? When do you think that came up?
Yeah.
Who said that? Pretty close. Yep. So actually, in 1955 or 56, 50 years ago, we've been shipping stuff for thousands of years. 50 years ago, we just figured out the box. So here we go. So once we figured that out, we got the containers. These are also different types of shipping containers that are out there. And there you go, in 1956. So Mr. Malcolm McLean came up with what's now known as the modern container. So, and now we see them everywhere. Now these containers are used everywhere. Look at that. Look at that storage space. It's amazing how much stuff is there. And what's more amazing for the managers, the first paragraph, hand loading used to cost $5.86 a ton dollars. After the invention of containers, 16 cents. 16 cents. 39-fold savings. Because of the box. Isn't that mind-blowing? So, containers came out and you could ship literally anything in a container. You could put anything you want. My friend shipped a car years ago. I know people move around. There's, we can put anything. We put racks in there. We can put all sorts of stuff. Boxes, I don't know, construction material, bikes, boxes, cars, motorcycles, boat. Let's shove a boat in there. We can do that. Flip it over. It's a square box. So containers are universal. Containers are universal. You can put pretty much anything in there, and they stack up. They work well. Why do they work well? Because they're standard. They take up. We know how much space they take up. They're easy to load, unload, and they're pretty simple and straightforward. So how do we ship these containers now? So we have trucks, we have trains, we have helicopters, we have all sorts of things. We have ships carrying containers, all the way from small ones, all the way to the big ones. We even have packs like that carrying containers. So how can we bring this idea into the software world, right? And that's the answer to that Docker, the question that Docker answers. So when we go to deploy our application, so the examples I'm using are a little generic here. So let's say we have a UAT environment, right? We have front end, some sort of front end running. We have scaled logic, business layer. We have database. We have caching instance, right? In staging, we could scale that out a little bit. Right now, with virtual machines with additional servers, we could have a little bit more load on on the front end. We scale out the logic, scale out the caching layer. In production, things are going to be much more serious, right? So we have a lot more scaled front end, logic, business logic, more processing, more caching required, and then redundant persistence layer, right? So how do we take the idea of shipping and plug it into this? How can we do that? How can we tackle this issue, or how do we actually do that now, right? So there is a spectrum of ways of shipping software right now, right? There's on one spectrum, there's the output of the Visual Studio build, right? So we build a project, and the files that we get, that we can give it to sysadmin or whoever, and just deploy that, right? So that's the simplest, the smallest unit of deployment, right? On the other spectrum, we have a virtual machine, right? So we can just wrap up the whole virtual machine, package it up, and just give them that virtual hard disk, right? So and just have them just spin that out. So the problem with this approach, with the binaries, right? We're just giving them the code for the application. We're not giving them everything that the application needs to run, right? There are all these other frameworks, libraries, dependencies, all these other things that your application may depend on, right? So we're giving it to them, and sysadmin goes like, well, what do? I just plug it in, and I don't know what it needs. I don't know what it wants. I don't know what else is out there. What ports do I need to open? What security? They're blindsided by it, right? And then we have all these issues. On the other end of the spectrum, we're giving them a whole virtual machine, which is a lot of crap, right? We're giving them the calculator, right? We're giving them the notepad. We're giving them all that stuff that they don't need. And we're also dictating how the server needs to be set up by giving them the whole operating system, right? We're telling them how to do their job. Would you like that? Someone telling you how to do your job? So the answer was kind of in between, right? And that's what Docker has figured out. Containers, what they did is they thought what we need to do is create some sort of isolated environment in which we can run our applications or processes and not affect other processes. Right? You can clearly see that now in mobile world, in Android, iPhone, clearly in Windows. Actually, clearly in Windows 10 with the new Edge browser, if you used it, you can't get to the post file now because it runs in its own container. It's an app. It's not a program. So Docker introduces the concept of container, which is running a process sort of in the isolated world. As far as that process sees, it's the only one. So Docker containers define how each process sees the machine that it's running on, right? So a container defines how much memory. Okay, you get this much memory. This process gets this much memory, and this process knows the CPU is this and this is that. So every process sees the machine differently, and you can allocate that. And everything that happens in that container, as far as that process is concerned, happens on a separate machine. You can't communicate. You can't affect each other. There's resource sharing, of course, on the back end, but you're in a very isolated environment. So that's what Docker is. So Docker came out publicly last summer, 2014. In just 1 year, it grew to the point where 40% of companies, corporate companies, adopted it. We're going to look at the slide right now. Look at this. 18,000%. I said that earlier. 18,000% growth. Have you ever seen anything grow that fast? Anything. Just Apple, anything, Microsoft products, anything. Look at that. Here, right here. That's where it went public. Middle of 2014. 500+ million polls. That's crazy. In a year. So that's from Dr. slideshow. Look at that. Look at the adoption rate. You guys know Red Hat, right? Red Hat Linux. Right here. Microsoft. You don't know Microsoft? Right here. That yellow line is the adoption rate of infrastructure software vendors adoption percentage from 2013 through 2015. Orange line is the metric taken in January 2015. So Microsoft, 2% difference growth rate adoption. Docker, mind blowing. So who uses this? Who is the main driver? I'm actually very excited about this because large companies, I would expect small or mid-sized to jump on it, right? Like the little guys are usually, more agile. They're usually at the top of the technology chain. Well, they are sort of 30%. Mid-sized sort of falling behind, but large companies are actually jumping on this. 56% of large companies are using Docker. Well, 50% of users are large companies, which is very exciting because what's Sitecore? Sitecore is an enterprise CMS, right? So our clients, Sitecore clients, are large companies. So that metric is very exciting, very important. So we mentioned containers and virtual machines. So how is container different from a virtual machine, right? So we're talked about how it has its own environment that it runs in. It's sort of an operating system, but it's not. So container is not a virtual machine. So virtual machines are full instances of the operating system, right? Obvious. Sometimes it's hard to set up. If you guys have been to the DevOps session, there's some cool tools that were shown bigger and some automation tools that you can use to set it up. But did you notice Corey sped up the video? Did anyone go to that session? There you go. Did you notice the video was sped up?
Yep.
Because I would have been synced here for a long time if I didn't, right? It takes a long time. It's still, you have to install it. Even though it's automated, it takes time, right? So containers. So what they did is, they thought, well, we really don't need the whole operating system, right? We really need just the bare bone. Just the base kernel. Just the foundation, what we need to run, plus some networking, file sharing, and that's it. That's all we need. So we came up with so they used TinyCore Linux for the Linux containers and Windows Server Core for the Windows containers, right? So containers easily duplicated, easily to start, lightning fast. Let me show you something real quick. Has anyone ever set up a Linux box? How long does it take you to install a box?
Half hour now.
Half hour now?
Machines.
Yeah. So what I have here is I have Docker running on my local machine. Boom. Ubuntu. Seriously. Exit. Do it again. Yep. Oh, oops. Another one. Third one. I just created 3 instances of Ubuntu. That's like, you don't believe me. Okay. So many things. It's hard to see. They're all blue, but these are.
Is this Cygwin or what terminal are you using?
Bash.
Yeah. On Windows? Yeah.
Mm-hmm. So,
Yeah.
yeah, it's the Git Bash. Yeah.
Get that.
Yeah. So, these are Linux folders. I created a full-blown Ubuntu instance. And then there's a demo, there's a video of what's his name, I can't remember. He was doing a video of deleting folders. So just to prove that all those instances are different. So let's, okay, there we go. So we have our folders, right? So let's kill, just kill and binary, right? So binary, boom. All of our binaries are gone, right? ls doesn't work. No commands work, right? Unisys. I can just keep doing it all day. Do I need, if I need another Linux instance, boom.
So exit is not a command within the OS is spun up. Exit is a command on the Docker level.
No, yeah. So exit. Yeah, you're exiting because when you run, when you get it. So what I did over here, if you look at the command, I said Docker run IT interactive terminal give you Ubuntu. So Docker space run space dash IT space Ubuntu space bash. So what I'm saying, create a Ubuntu container and give me the bash. So when you type in exit, so when you pass it the command, Docker puts you into the execution of that command. So when you type in exit, you're exiting not from the container without you're exiting from the execution of that command. So timing core Linux, right? So then you're thinking, well, wait a minute. So we're gonna put an operating system on our Docker, or on our we heard you liked operating systems, right? So we'll put an operating system on your operating system, right? So we put a little operating system on your operating system. It's still a layer, right? So you're wondering how many resources is that going to take? Tiny core Linux, 24 megabyte download. Runs completely out of memory. 46 megabytes of RAM. That's a tab. That's your Chrome browser tab. Seriously, open your Chrome, check it. It's going to be more than that. i486 DIC. I was just several years old when that was built. So that it's nothing. It's like 50 megahertz processing power. Recommended requirements, well, double that up, open two browser tabs, and slap up Pentium 2. Still nothing, right? Very lightweight. Windows, well, you think Windows is bloated? It's a bit bigger, but 256 megabytes, 1 gigahertz processor, 486 for 64-bit, 1.4, a bit more thinking. And I recommended 512 and 2 gigahertz processor. So it's not much more. But Windows is a bit more complicated, right? Windows is bigger than Linux, right? Because Windows runs on so many machines, so it has to be bigger, right? So you just can't make Windows smaller. People say Windows is bloated. Well, Windows is bloated because it just has to run on everything and account for it. So there you go. That's a little bit of a trade-off, but still not much, right? So containers. So why do we like containers? So we talked about them being fast, talked about them being lightweight. Well, what do they help us do? They help us make DevOps a reality, really, essentially. They help developers. They allow developers to do operations, right? We're creating immutable infrastructure. We're creating applications inside the container. We're loading Ubuntu. We're deploying an application, and that container now becomes our unit of deployment. So we're not deploying an application. Your continuous integration is no longer pulling the code from the repository, building it, and deploying that code and just dropping that code in. No, your CI is now just simply pulling the container. Your developer is working. Let's say you're a developer and you're going to work inside of the container, right? You're working inside of the container. Once you're done, save it. Get it into the repo. CI pulls the container, and it's no longer merging. It's killing the old one, putting the new one in. It's an immutable infrastructure, right? So that way we make sure that every single environment is exactly the same, right? We're deploying what we have on our local machines to QA, to production, to UAT state. Of course, configuration differences, right? Of course. There are ways to overcome that. We'll look at the Docker file. There's things we can do to make those environments different. The configuration of the environment is different. But essentially, you're creating the same environment. So And think of containers, one more thing is, think outside the box. There's one way, and we'll look at it in a bit, there's one way to run containers where you can run an instance of Mongo locally, right on a container, or Solr on a container. But think further. Think microservices. Think isolation concerns, right? Think components. Think just composable infrastructure, right? So you can split your application. Let's say we're running on Sitecore, right? You can split your caching. Let's say caching service. Split that onto several containers. You know, don't think that there's just one Sitecore server, because we're used to thinking there's just one Sitecore server. We're just going to bang on that door all day long, right? We need some help with MIDI assets. We got a CDN, but we can create containers in front of that, right? We can bang on containers instead of Sitecore. We can create service-oriented architecture, right? If we're Peter was giving a talk on mobile SDK, right? There's no page editing. We don't need to hit the server, right? We just need to get the data. Create a caching layer out of it. So try to sort of think through these scenarios how you can apply that with the lightning fast speed of containers. What we're doing is we're bringing Azure. Why was the cloud so attractive at first, right? We don't have to do sysadmin work. One, the big one. But two is we can easily create infrastructure, right? We can easily spin that out. We can easily make deployments, right? It's all automated. It's all just at a click of a button. We can, instead of deploying maybe our CI deploying once a week, once every couple weeks, we can get up to deploying 100 times a day. Because we're deploying a container. We're not deploying code, right? We're replacing it. Amazon, this blows my mind. Amazon deploys every 11.6 seconds. Every 11.6 seconds, Amazon deploys new features, code. Just think about it. Just take a second and think about it. What is, right? So so this is now possible with Docker. So hosting containers. So where can we run Docker? We can run it locally. So we have two options. There's Docker Toolbox. It used to be moved to Docker project. It grew into matured into Docker Toolbox. When you download that, you get a VMbox virtual machine. Then you get a boot to Docker, kinematics, I think, and a Git bash. So Docker uses Git for commits and pushes. And we'll look at that, how that plays in. Hyper-V. So Hyper-V containers, that's for the Windows world, right? So Linux containers have been around for quite a while. Linux started playing with containers 5-6 years ago. So it's slowly progressed to the point, starting from small isolation to isolating entire services, process IDs nowadays. So it's been coming. Windows jumped on the train recently. So Hyper-V is very new. If you went to the Rackspace presentation on containers, they showed Windows 2016 Tech Preview 3 demo. That's the first release of Windows Server with containers. So it's pretty unstable. I played around with it. I was going to demo it. It's crap right now. So if you have short nerves, don't use it. Wait till it gets a little bit more stable. But definitely play around with the Docker Toolbox. Okay? Azure. Containers are already on Azure. You log in and if you're familiar with Azure, when you go to select an operating system, there will be an option book onto with Docker, or something Docker. So you'll see you can install an operating system with Docker already built into it. And of course, there's service providers like Rackspace and others that also make use of Docker and have that available. So that's great, right? So Docker, lightning fast, super portable, right? We can spin out instances left and right, close them down, delete them, do whatever. Very lightweight, doesn't take any resources. So how do we ship that, right? So how do we actually get it from point A to point B, from our machine to wherever it needs to go? A couple ways. We can create an image. So once you're done configuring, let's say we're setting up Solr, right, on our container. Once we're done with the configuration, Because how many times as backend developers or architects or sysadmins, you have to set it up on your machine. Once you set it all up, you go to someone else's machine and set it up if it's easy enough, right? If not, you're, again, trying to come up with a hack, put it on a flash drive, wrap that virtual machine and put it on that, on there. You're trying to recreate that same environment, right, for other developers. You're trying to write a script, you're trying to automate things. So here, what you would do is, you would simply create an image and just, put it on a share, put it on a flash drive. There's a public repository. It's called, well, it can be public, it can be private. It's called Docker Hub. So you can upload it on there and just share the URL. Or you can create a Docker file. Docker file is very lightweight, text file. It's an instruction file. So what that does is it just has a list of instructions for creating the container. Right? So you're not giving them that image of the container, you're giving them the instructions. And the important thing to know, when you're shipping an image, you're not actually shipping the entire operating system, you're shipping the Delta. So you're not shipping gigs. Depending on what you install, you're shipping the different, you're shipping what you've installed. Right? Docker is smart enough to figure out, uses get difference to figure out what we actually need to ship. So that the image is just the Delta. And then again, shared, distributed, Docker Hub, network location. That's a Docker file. So that's an example right here. Okay, so I'm gonna rush through this. So Windows Server container. So just like we said, developers no longer deploy the application; they deploy a container. Right? Developers work on their local machines, push the container into the repository. Operations grabs that, CI pulls it into the servers. Right? So it's no longer your source code is no longer a unit of deployment. Tools. So we have PowerShell for Windows containers, Docker, Visual Studio, Azure. We already talked about that. Finally, an hour and a half presentation, right? So Mongo and Docker. So just like we said, we can simply run Mongo on one instance of Docker, right? Locally. How I as a developer can benefit from it, right? So let's get this guy back out here. So let's say I need a Mongo instance, right?